When your design involves a powerful microprocessor with gigabytes of RAM, maybe multiple cores, GPUs, high-speed interfaces, it opens up incredible possibilities. But it also presents a complex challenge. What operating system do you put on it? The decision here is massive. It affects everything from development speed and cost to real-time performance, user interface capabilities, and long-term maintenance. I am Sarana Pandian, CEO of MPU Technologies, and for more than 23 years working on embedded systems, we help clients create powerful MPU-based embedded systems. Unlike most MCUs, MPUs have a memory management unit. It allows for virtual memory process separation, meaning one application crash is less likely to take down the whole system. It enables running complex operating systems that require more resources in the same time, opening up a world beyond simple schedulers or basic RTOS kernels. So what are these options and how do you choose? The primary players you encounter for MPU-based embedded developments are embedded Linux. This is probably the most common choice today. It's a full-fledged Linux kernel tailored for your specific hardware using build root systems like Yocto project, Buildroot, or customized distribution images like Ubuntu Core. Why choose it? Open source option with vast ecosystem including mature drivers, libraries, networking stacks, proven process separation capabilities offering stability and flexibility. It has a huge community and developer pool. Typical use cases: IoT gateways, industrial automation, networking equipment, digital signage controllers, robotics, complex headless devices. Embedded Android. Based on the Android open source project EOSP, this brings the familiar Android environment to embedded hardware. Why choose it? Excellent for rich graphical user interfaces, it provides a robust application framework and sandboxing, access to a large developer base familiar with Android app development, and a strong multimedia support. Typical use cases: automotive infotainment, consumer electronics with displays, smart appliances, kiosks, retail point of sale systems. High-end RTOS, real-time operating systems like VxWorks, QNX, RTMS. While RTOSs exist for MCUs, these are more powerful versions designed for MPUs, often focusing on safety and deterministic performance. Why they are used? Primarily for hard real-time guarantees, robust safety and security certifications that are critical in automotive, medical, industrial control, and proven reliability in demanding applications. Typical use cases: safety critical industrial controllers, medical devices, aerospace and defense systems, advanced robotics requiring strict determinism. There are other less popular options such as running bare metal or scheduler on one or more of the cores to enable small but high performance tasks. Windows IoT from Microsoft is still available on very limited platforms. The challenge of choices. Within Linux or Android, there are further choices regarding distributions, build systems, and versions. Selecting the wrong one can make development incredibly difficult, impact performance, or even limit future features. So, how do you cut through this complexity? It comes back to a structured evaluation process. You need a framework to map your project's requirement to the capabilities and trade-offs of each platform. Let's get into the framework criteria. Criterion 1. Application functionality and user interface needs. Does your device need a rich graphical interface? Does it need to run third-party applications? This points strongly to Android. Is it a headless device? Both Linux or high-end RTOS are good fits. Does it need complex multimedia processing? Android or Linux with appropriate drivers and libraries excel. Criterion 2. Real-time and performance requirements. Are there hard real-time deadlines that must be met with microsecond precision? High-end RTOS is usually the primary choice. Sometimes RT-patched Linux helps. Or is it soft real-time where occasional delays are acceptable? Standard Linux or Android are usually fine, especially for UI and networking tasks. Criterion 3. Resource constraints. While MPUs have more resources than MCUs, they aren't infinite. Android requires significantly more RAM, flash, and GPU power than a minimal Linux system or an RTOS. What are your hardware limits, and how do you match the OS needs? Connectivity and communication. How critical and complex is networking? Linux has the most mature and flexible networking stack built over decades. Android is also good, inherited from Linux. RTOS networking stacks exist but might be less comprehensive or cost extra. Criterion 5. Security and safety requirements. Does your device handle sensitive data, require secure boot, encryption, trusted execution environments, need safety certification like IEC 61508 or ISO 26262? MMU-based OSs offer process isolation. Specific certifications often point towards validated RTOS or specific Linux distributions or variations. OTA update security is also a key here. Criterion 6. Development ecosystem and team expertise. What OS are your engineers familiar with? Is there a mature, well-supported BSP from the silicon vendor for the OS you are considering? What tools, IDEs, debuggers, and middleware are available for that OS on your specific MPU? The quality of the BSP is often a critical factor in MPU development success. Criterion 7. Cost. Consider both per-device licensing cost and the development cost. While Linux is free in terms of license, the effort to build, customize, and maintain a production-grade Linux distribution can be significant and requires a specialized expertise. Criterion 8. Boot time. How quickly does your device need to be fully operational from power on? High-end RTOSs typically boot much faster than Linux or Android, which need to initialize more hardware and load large kernels and file systems. Criterion 9. Long-term maintenance and updates. How will you provide updates to devices in the field? What is the long-term support commitment for the OS version, kernel, and drivers from the vendor or community? This is crucial for the lifespan of your product. Beyond the framework, navigating these criteria is key, but from my experience, there are few extra points to keep in mind. The BSP is your foundation. For MPUs, the quality and completeness of silicon vendor's board support package for your chosen OS and board is paramount. A poor BSP will cause endless pain regardless of how good the OS is conceptually. Build system matters. Choosing between Yocto, build root, or a simpler approach within Linux has huge implications for customization, complexity, and long-term maintenance. This is almost a sub-framework decision itself. Hybrid architectures. For complex systems needing both hard real-time and rich OS GUI, consider a multiprocessor approach or a hypervisor to run an RTOS on one core and Linux or Android on others. Community and commercial support. Open source OSs have active communities, but commercial options often come with dedicated support channels and warranties, which can be vital in critical applications. Don't underestimate complexity. Whatever the support is available, be prepared for kernel-level debugging, driver issues, and more complex build environments. In conclusion, selecting the software platform for your MPU-based embedded system is a strategic decision that requires careful consideration across multiple dimensions. Linux offers flexibility and a vast ecosystem ideal for connected and complex general-purpose devices. Android excels for rich, interactive user interfaces and app support. High-end RTOSs are a choice for safety-critical, hard real-time applications requiring certification. By using a framework based on your application-specific needs for UI, real-time resources, connectivity, security, development ecosystem, cost, boot time, and maintenance, you can confidently choose the platform that provides the best foundation for your product success. I hope this framework helps you navigate the exciting but complex world of MPU software platforms. If you found this discussion valuable, please hit the like button and subscribe to the channel for more insights from my team's decades of embedded experience. And if you need expert assistance in selecting or developing on complex embedded platforms like these, visit us at www.mbn.com. For a free consultation, visit the link given in the description below. Thanks for watching, everyone. Let us continue building the future, one embedded system at a time. See you next time.